So today we are going to introduce our relationships unit, and we are going to be talking specifically about graphing. A graph is a way to visualize or visually represent, I'm going to say, the relationship between two variables. So that's our key thing to remember. Now, there's a couple different things we could do. The first, we can go from a graph to a statement. So I'm going to draw out my introduction graph here, and I'm going to label my y-axis cost to make a movie. I'm going to label my x-axis, so that bottom line there, the length of movie. This is one of the example questions that we're going to go over. So I'm going to plot 2 points on this graph because that's what I'm going to be given here. If you're not given the points where you're given numbers, you want to be more particular about this, but this example is using known numbers. So it's kind of an estimation or a prediction and just our understanding of what a graph can say. Now we want to determine what can we actually find when we are reading a graph like this. So obviously we don't have numbers, so we're not getting data points, but there are 2 things that we can find. So the first is that both of these movies cost the same to make. Okay, so cost the same to make. Sorry, sometimes I speak faster than I write. So we can see this on the graph here when they're at the same level, just like that. The next thing that we are able to determine, I should have labeled these movie A, movie B, and I'm going to write a title here as well. So movie A is longer than movie B. Let's see if the movie is progressing. Based on our general understanding of a timeline, we're going to be able to see that this is an increase in time. If we're going to write everything in one sentence, this is kind of how we want to be aiming to do it. So the length of the movie does not change the cost of the film. Okay, so that's graph to written sentence here. We also have another thing that we can do, and we can go from a written sentence or a phrase to a graph. Rides his bike to school, first up, then down a steep hill. Sometimes a question will ask you then which graph and give you options, and other times it'll ask you to draw a graph. So first up and down a hill, which graph below represents the student's speed as compared to the time elapsed or time passed? And you just write as time passed. Okay, so we're going to draw a graph that compares speed to time here based on what I have read so far. So we're going to start by drawing out our frame for this graph and then labeling our y-axis and our x-axis. Time, always on your x-axis here, does not change. So I'm going to start by asking myself a couple of questions. Okay, after I've written the title here, sorry, always forget about my titles. Bike ride to school. So after we've written the title, we've labeled our axes, we're going to ask ourselves a couple questions in order to draw this graph correctly. The first question is, what happens when I ride my bike uphill? Okay, well, when I ride my bike uphill, I get tired, I have to apply more force, and it's going to take me a little bit longer or more effort to get up the hill, so my speed might decrease. That's the first thing that we can see here on this graph. So I'm going to draw that line down. The second part of this question is then down a steep hill. So what happens when I ride my bike down a steep hill? Going downhill, okay? Well, I usually pick up speed, so that graph is going to curve all the way back up. When we do apply curved lines here, because our speed is not consistent. A straight line would imply a consistent speed, but a curved line implies a change of speed or acceleration, what we call it if you take a physics course. So just to be very clear here, this red line represents what we do not want to happen. So I don't want to see a uphill line and a downhill line just because we are